Okay, today we're gonna talk about the anion incorporating a main group element. So here I just quoted IDE, IDE, this element only with minus, like sulfide, S, bromide, Br. So if the element is negative charged, so we can give the symbol or ide. If the element has some oxygen and it's negative charge, so we can give it like ite. Ite here, I have oxygen, 3 oxygens. So the name will be changed to ite, like sulfite. Sulfite is SO3 minus 2. Where here is sulfide, it's is S or bromide on its own, but here with oxygen, with we call it less oxygen, or so we can give sulfite. Ite will come with the name or the root. We call it here, the half of the salt will be SO3 minus 2. If it is more oxygen, lots of oxygen, so we can call it sulfate. Okay, so this is a sulfate, SO4 minus 2. And we will talk about where these minuses came from. So as you remember, just to for a summary, as XX, or it's a covalent bond in the halide oxygen, in the halide gases. So they are at X2, like Br2, I2, Cl2. So the bond between them is a covalent, is a cooperated bond. So there is no electronegativity change in both atoms. So we can give the will be covalent bond, where the polar covalent bond, when there is a X and Y, different atoms, and then we can give it, the 2 electrons will go to the higher electronegativity. So that will be polar, because here will lose the electron temporary or partially, and then this atom will gain these 2 electrons beside it, and then the bond will become polar. And here we have some polar covalent bond will be XY. Here, if there is a metal, the metal lose electron to give it to the halide or the halogen, and then the halogen will be fully saturated, whereas the metal will be like stable and no more single electrons has. So here will be ionic when there's a metal, like NaCl. So there's a metal, there is a halogen, and the 2 electrons go to the Cl. So that will be the ionic bond. So the metal will go, after losing electron, will become positive charge, whereas the halogen gained extra electron to become negative charge. Now, so here, this is what the metal become, like it's 2 electrons beside the halogen, and the metal will become, we lost the electron, so will become positive. Okay, so here dative bond, this is in the coordination chemistry. We can see the halogen can donate pair of electrons to the empty orbitals ny metal and become a coordinated bond, or we call it dative bond. Now, common anions found in the combination with group 1, 2 metal ions. We can see in this group called nitrate. So nitrate 8 here, this is the highest oxygen with the nitrogen, so it will take 8, symbol 8. If I have less oxygen, so with the nitrogen here, it will be nitrite. Okay, carbonate CO3. This is the highest number of oxygen can bonded to the carbon. It will be CO3. So this is carbonate. Where here I have H, so it's a hydrogen carbonate, and the overall charge is -1. Here, carbonate, the overall charge will be -2, and we will explain this later. Phosphate, this is O4 with the phosphorus, the highest bonded oxygen to the phosphor will be 4. So this is the high, so it will be phosphate 8. And the overall charge is a -3. Hydrogen phosphate will be HP, and here as a group HPO4, and the overcharge is -2. Why -2 here, -3? Because of the hydrogen. The hydrogen came inside, so equalize another minus charge, and that became less by 1. So the -3 became -2 because of the positive charge of hydrogen. So that will reduce the overall charge. Sulfate, SO4 -4. Sulfate 8, or sulfate. Hydrogen sulfate will be less by 1 charge, so it will become -1. This is the overall charge is -1 with the hydrogen sulfate. Sulfite, SO3. So this is less oxygen, and the overall charge -2. If you add hydrogen, the minus lose 1, become -1. Permanganate 8. So permanganate. So permanganate is MnO4. The overall charge is -1. Whereas the dichromate is Cr2O7, and the overall charge is -2. We explain this later. Cyanide, this is Cn. The only one is cyanide. If you add thio for the sulfur, it will become SCN. The overall charge is still -1. Hypochlorite is -1, where there is OCl. The perchlorate is a ClO4, and the overall charge is -1. Example of ionic compounds with group 1 and 2, cations. Cations means positively charged. Potassium permanganate. So you remember MnO4 was the minus charge as a group. So once potassium lost the positive charge, it's a positive charge potassium, negative charge of MnO4, the overall charge here will become zero. Okay? So potassium permanganate overall charge is 0. So there is no positive, no negative. On the top of this molecule, it means the charge is 0. Contains ions of potassium and ions of permanganate. So once they combine together, they will be equal or even, and both will lose the charges when became one molecule of potassium permanganate. Sodium chloride, the salt, contains ions of sodium and chloride. So the sodium plus charge, chloride minus charged. Why minus charge? Because the sodium lost one electron to chlorine. When lost, became positive charge, and this one gained the electron to become minus charged. So now we have sodium and chlorine, positive and negative, will become neutral, will become salt, and the salt is stable, no charge on the molecule. Magnesium chloride, similarly, magnesium have lose 2 electrons to give it to the chlorine, and the chlorine will get 2 minuses. This is 2 times minus will be 2 minus. So when this is lost 2 electrons, this gained 2 electrons, and here combination of them will be magnesium chloride. Overall charge is what? 0. Cesium hypochlorite. Cesium hypochlorite. Cesium lose 1 electron to give it to the hypochlorite. Hypochlorite became minus, cesium became plus. So now plus and minus together inside will become cesium hypochlorite. And the overall charge, 0. Magnesium dichromate. Magnesium dichromate. I remember chromate is -2. How? Because it gained 2 electrons from magnesium, the oxidation state of magnesium +2. It means magnesium can lose 2 electrons in one go. These 2 electrons, when lost, came to the dichromate. The dichromate became -2. So these -2, actually they are 2 electrons from the magnesium. The two pluses here means the magnesium lost 2 electrons, lost. So this lose, this gains, and both of them became neutral in the magnesium dichromate. If we know how -2 appears here, we can come inside here and see in another way. 2 chromate, the oxidation state of the chromate is a +6. Okay, 2 times +6 will be 12. Okay, 7 atoms of oxygen, each oxygen is -2. So 7 times -2 will be -14. So if you add -14 to +12, it will remaining -2 or 2 minus. So this, the 2 minus is the overall charge of dichromate. So we need to know something. Each element seeks stability of a filled shell or subshell of electrons. So always the element seeks stability. Stability, it means it will become neutral. And ions in the nature, they don't stay as anions. Always, because they are active, radicals have single electrons. So these ions quickly react with another cations. So an ion, we said ions. Ions means cations and anions. So the anions minus charged, cations positive charge. Always in nature, they combine together to be neutral, to be stable, and we can see them in the nature in types of called salts. Thus, they will gain, lose, or share electrons to achieve stability. Sodium and water, and this is very dangerous. When you add sodium to the water, it explodes. So we don't do this, but we have to separate the water for hydroxide and half H2O. So in this case, half hydrogen gas and hydroxide will become water. So the hydroxide will react with the sodium, give the electron to hydroxide, and then it will become sodium hydroxide stable and hydrogen gas. Okay, the hydrogen gas zero charged. Why? Because it is stable. Two hydrogens, one share the electron with the other one. Both of them, they are stable, zero charged. If we come to sodium itself, by itself, it is stable. Stable means zero charge. And always they save the sodium under petroleum or paraffin because it will react with oxygen and water or moisture. So the sodium, dangerous, valence, because it has one single electron in the outer shell, where the atomic number is 11. So it's 1s2, 2s2, 2p6, 3s1. 3s1, one electron means radical, means active, means needs quick sharing or give or lose this electron for another molecule and become hydroxide, sodium hydroxide. So the sodium hydroxide here, if you can count how it is stable, how it is zero. Sodium by itself, if you cover the two, but this two came from the equation, equilibrium of the equation or balancing the equation. So if we deal with the NaOH, Na plus 1, or the oxygen minus 2, the hydrogen plus 1. So if you see plus 1 and plus 1 plus 2, minus 2 will become 0. So the overall charge of the sodium hydroxide oxidation state is 0. Here's the sodium. Sorry, this is the water, and this is the sodium. This is hydrogen. When there is half gas of hydrogen, it means one hydrogen with one electron. So sodium here lost electron to the hydroxide. The water dissociated, destroyed, or break down to hydroxide and hydrogen. So hydroxide and hydrogen, and left with OH. So here, if you see the oxygen has how many electrons? 8. and the hydrogen has 1 electron. So here we have 1s2, 2s2, 2p, 4. So six electrons belong to the final shell of the oxygen. And this electron in X, it came to the oxygen from the hydrogen. And then in this case, we have 2, 4, 6, 7, 8. 8 electrons in total for the hydroxide. It is stable, and this minus is from the other donation of came from the sodium. So the sodium lost electron. This is it. Sodium lost, so left with positive charge. Oxygen received 1 electron. So here originally the OH is stable with 8 electrons, and this, the 9th electron came from the sodium. So always we say OH minus and Na plus. Together they will make sodium hydroxide. Ionic chemistry, halide ions tends to combine with group 1 and 2 metal ions. So we usually use the short letters. G means gas, AQ, aqueous, S, solution, L, liquid, S, solid. That's always we use these shortcuts, short letters, to describe the status of the gas or the matter. So the status of the matter here, Cl2, we don't write gas, we just give it as a G. Plus 2 NaOH, NaOH is aqueous. It's aqueous in the water, dissolved in the water, sodium hydroxide. The reaction between chloride gas and sodium hydroxide will be salt, NaCl, solid, and sodium hypochlorite, solution, and water, liquid. So with outer halogens, the halide chloride, Cl minus, and hypohalide when there is oxygen with it. So they formed hypochlorite, sodium. Oxo anions and halogens. So let's have some of these groups always comes with there is oxygen and halogen together. So if you see here, there is oxygen with the chlorine. So how can they combine together? Can it takes 1 oxygen or 2 oxygens or 3? When there is 1 oxygen with the chlorine, so the chlorine, if you see the outer shell has 7 electrons. 1s2. So you remember the atomic number of chlorine is 17. So it will end up with 4s2, 4p5. So 2 and 5 will be 7. Oxygen at the end is 2s2, 2p6. Is it 4? 2s2, 2p4. So it's 6 electrons. And here we have 7 electrons. They combine together. So 1 single electron with single will form the bond. And here the minus is overall charge. So chloride minus lost 1 electron to oxygen with minus electron, the difference between minus 1. So the hypochlorite is minus charge. Overall charge is minus 1. Why? Because the difference between the oxygen and chloride, oxygen -2, chloride is -1. The difference between them is -1. Now, if we come to the halite, some oxygen, we said, ClO2 here, the chlorine form double bond with one oxygen and single bond with the other oxygen. So here we have, you remember there is 6 electrons around the oxygen, and we have here a single electron bonded. So 2 of the chlorine electrons bonded to 2 single electrons of oxygen. The other single electron of chlorine bonded to 1 electron of the outer shell of the oxygen. And if we count, there are 2 oxygens, each one has -2. So 2 times -2 will be -4. Chlorine here lost 3 oxidation number here. Chlorine, when it's bonded, once each single electron bond to other oxygen and 2 here bond to other one, it means lost 3 electrons. So here the oxygen 2 and 2 and -4 electrons. Chlorine lost 3, so it's +3, -4 plus 3 will be -1. So the overall charge still is -1 for the chloride. Okay, if you come here, just leave this structure or the lines structure, and you come to 2 times 2, 4. And here the 3 of the chlorine, so 4 and minus, and the bonded 3 electrons of the chlorine, the difference between them is -1. Here we have the perchlorate with 4 oxygens. So the chlorine, if you see, involved in what? Chlorine lost how many electrons to form double bond, single bond. So all 7 electrons of the chlorine lost for bonding. Remember, 7 electrons lost for bonding, because every double bond is made of what? 2 electrons from chlorine, 2 electrons from oxygen. Okay, here we have 1 single bond. This single bond formed from 1 electron of chlorine and 1 from oxygen. As you see here, we just count the double bond, single. 2, 2, 2, and 1, 7. So the chlorine is 7 plus. Okay. Now we come to the oxygen. Oxygen, 4 oxygens. What they did for oxygen, 4 times 2 minus will be -8. So -8 plus 7 remaining -1. So now we have here the shorties of hypohalite. It's the halogen and oxygen -1. Hypohalite. Like what? Hypochlorite. ClO -1. Hypochlorite. Halite is when there is 2 oxygen and 1 halogen. This is a halite. So we can call chlorate. And now halite, when there is 3 oxygens involved, halite. So we have chloride. And when there is 4 oxygen, per halite, like per perchlorate. Now, perchlorate. Now we want to see how these been formed. You can see the structure of the perchlorate. So it's a chlorine and 4 oxygens, 3 oxygens double bonded, 1 oxygen single bond. So the overall charge is -1. Okay, so now if you come to the chlorine, 17 electrons, 1 s2, 2 s2, 2p6, 3 s2, 3p5. All the halogens ending with 7 electrons, 2 in s, 5 in p. Okay, bear in mind, all halogens ending with 7 electrons in the outer shell. So the 7 electrons here, the main final shell has 7 electrons. We say, okay, 7 electrons. And now oxygen, 4 oxygen, 1, 2, 3, 4 times -2. Original oxidation states of the oxygen is -2. So here we have -2 times 4 will be -8. So -8 plus 7, these 7 electrons, because all these 7 electrons involved in bonding. All these 7. These 7, 2 here for double bond, 2 here, 2 and 1. 2, 2, 2, 1 will be 7. So 7 electrons lost from the chlorine for bonding. Each oxygen has 2 minuses. 4 oxygens, 8 minus. 8 minus plus 7 will become -1. So the overall charge of perchlorate group is -1. We take this sulfate. Why overall charge of the sulfate is -2? This is the sulfate, but the sulfate ending with 6 electrons, 3s2, 3p4, 6 electrons. 6 electrons means they can be donated to the oxygen. And the oxygen will take 2, 2, 1, 1. Because we have 4 oxygen, so you put 4 oxygen around the sulfur, and the sulfur, you have to donate 6 electrons for these 4. So what we're gonna do? 2 electrons to do double bond for 2 electrons to this oxygen. 2 electrons from sulfur with 2 single electrons to do double bond for this oxygen. And remaining 2 electrons. One will form single bond with the oxygen, and the other one will form another single bond with this oxygen. So in this case, I have 6 electrons to be donated from the sulfur. I have 8 electrons extra of the oxygen. The difference between them is -2. -2 is the overcharge, overall charge over for the group of sulfate. Okay. Phosphate, we'll see that phosphate at the end. Phosphate has 5 electrons. Can give them all for 4 oxygens. Okay, 4 oxygen, they say, how can we deal with your 5 electrons? 3 of us will take single electron from the P, and the 1 oxygen can get 2 electrons. So 2, 1, 1, 1, 5. 3 and 2, 5. So 5 electrons of phosphor formed 3 single bond with 3 oxygens and 1 double bond with another oxygen. If we count now, phosphor donated 5 electrons from the outer shell. Oxygen originally have 8 electrons. Each oxygen comes with -2. 4 oxygens, -8. So -8 plus 5 together will become -3. So this -3 is the overall charge of the phosphate group. Okay, it belongs to all group. This and then why this happening? Because these groups, when react with metals, they will use only overall charge. Okay, so the overall charge of the group is the only charge react with the metal. Don't look inside, say halogen, oxygens. No. You have to deal with the whole group as one atom. We call it one group. This group has -1. So -1 perchlorate, if react with sodium, it will be sodium perchlorate. Only one sodium used. If magnesium, the magnesium comes with 2 electrons. So we need the perchlorate use 2 groups of them. We need 2 groups of perchlorate to make a molecule with the magnesium. Okay, if you come to the sulfate, if you bring the sulfate with the hydrogen, the sulfate says I have overall -2. So I need 2 hydrogens to react with. So the sulfuric acid is H2SO4. Why H2? Because of the sulfate has 2- overall charge. So when you have 2 minuses, I need to react with 2 hydrogens. So H2SO4 is the structure. You can find HSO3, not HSO4. Okay. If we come to the phosphate overall charge is -3. So if I bring him like 100 atoms of hydrogen for one group of phosphate, what the phosphate said I have overall charge -3. It means I need 3 electrons from these atoms. What are they? Hydrogen? Come, 3 hydrogens with me, and we can form H3PO4. H3PO4. It cannot be H2PO4. It cannot be HPO4. It should be always H3. Why 3 hydrogens? Because of the 3 overall charge of the phosphate. That's how chemistry reacts. Reaction will react with the valence electrons, with the valence electrons, with the outer shell electrons. Okay. So now we come to the octet rule. Atoms obeys octet rule when it gains, loses, shares electrons to give an outer shell containing 8 electrons with the configuration of S2p6. So this is the octet rule for the simple or smallest molecules. They can form a stable molecule, okay, or compound when the outer shell has 6 electrons, and 2 will become 8. 8 is what we call it octet rule. So this rule is restricted for small number of elements, like CH4. So the C is 6, 1s2, 2s2, 2p2. So how many valence electrons has the outer shell? 2 and 2, 4. So how many hydrogen we need to make octet? We need 4 hydrogen. So that will form the methane. Methane is being formed from 1 carbon and 4 hydrogen. Okay, 4 hydrogen. 1 carbon, 4 hydrogen. Why? Because the carbon has 4 electrons in the outer shell. 4 valence electrons. 4 single electrons for reaction. So these 4 singles needs 4 hydrogens. 4 and 4 together, they will form CH4. Sorry, not like that. So it's like the carbon comes with 4 hydrogens and then becomes CH4. CH4 is very good for octet rule. H2S. Okay, give me the sulfur. 16, 1s2, 2s2, p6, 3s2, 3p4. So 4 and 2 in the outer shell, 6 electrons. If 6 electrons sulfur has, how many hydrogen needs? Needs only 2 hydrogen. So 2 hydrogen, 2 electrons. With 6 electrons of the sulfur will become 8. So H2S at the outer shell being formed, this molecule, by 6 electrons from the sulfur, 2 electrons from the hydrogen. Together, octet rule, H2S, stable, 0 charge. So on with this one, if you see CF4, why we give the molecule CF3, CF2, or CF? Why? Let's count and see if they obey octet rule or not. So fluorine, 9 electrons, 1s2, 2s2, 2p, 5. In the outer shell, we have 7 electrons. So how many carbon they need? 7 electrons. So we need only 1 carbon to give 1 electron. So in this case, we have as 7 electrons and 1 from the carbon will become 8, and the carbon have used all 4 valence electrons to be octet. So here, in this case, the halogen can do different ways of using the 3 pairs of 3 pairs of electrons. There are 6 and 1 remaining of the carbon. So in total, CF4 can obey the octet rule. Now let's see how this happened. FF, the F halogen, outer shell, 7 electrons, 3 lone pairs, double bond, double electrons, double, we call it lone pair. So 3 lone pairs here with single electron, 3 lone pairs here single. Which one can form electrons? Is it the lone pair or the single pair in the halogens gas? So the single electron can form single bond. So these will be stable in their outer shell. Single electron will become single bond. So now here we can see F2 gas using valence electrons to do covalent bond. NH3, so the nitrogen has 7 electrons with the 3 hydrogens. Each one will bring 1 electron, so it will become NH3. Okay, so NH3, the nitrogen ones have 7 and take from each nitrogen 1 electron, so the nitrogen will become 8 as 2 nitrogen hydrogen single bond, 2 electrons single bond, 2 electrons single bond, and 1 left as a lone pair. So the nitrogen in the ammonia is has extra free lone pair. So this ammonia is very active because of the lone pair. And the nitrogen are stable, made single bonds with the nitrogen. So one nitrogen, the nitrogen has 7 electrons, and so altogether with the hydrogen will become 8, and the 8 involved 3 pairs of electrons to do single bonds and 1 free. HF, so the fluorine can take 1 electron from hydrogen to do single bond, and then the outer shell of the fluorine become 8. 8 electrons, octet rule, stable. Carbon with 4 hydrogens. So the carbon has outside 1s2, 2s2, 2p2. Okay, carbon 6 atomic number. So it has 4 single electrons. It needs 4 hydrogens. So 4 electrons from the 4 hydrogens and 4 electrons from itself become 8 electrons surrounding the central atom. This central atom obeys octet rule. Oxygen and 2 hydrogen. So oxygen and 2 hydrogen. Similarly, the oxygen 1s2, 2s2, 2p4, it has 6 electrons outside. 6, 2, 2, and 2. So these 2 singles electrons will form single bonds with hydrogen, and the 2, 4 electrons, they will remain as a pair of lone pairs, 2 lone pairs, and the water become octet. The oxygen in the water obeys the octet rule. CF4 is similarly. So in a molecule, the octet rule applied to the center atom surrounded by 8 electrons. So the octet rule belongs to the central atom, not the surrounding. Bonding models. We can stop here and continue later.